from, that would be great. So nice to see everyone today. Thank you so much for joining us for part 2 of the RiSWP teaching series. I'm Sandy Moskowitz, the program director at SWAN, and thank you all for joining us today. We're very excited for this second episode led by our RiSWP leadership team. And we're really excited to be featuring Jennifer Morales, the Public Works and Asset Manager of the City of Omaha. So before we get started, just a few quick RiSWP updates, some exciting news and things that we have going on that we'd love for you all to get involved with. So at RiSWP, with the help of our leadership team and our ambassadors, we are working to develop a smart water career portal, really helping to connect talent in the industry with organizations that are seeking talent. So if you're either a job seeker or an organization that's seeking talent and you want to share some of your feedback, maybe challenges that you've had in the past or successes you've had in the past with connecting with talent, we'd love to hear about it. So we'll drop some links in the chat for you in just a second, so you can sign up and get involved, and we'd love to have you guys part of that. We recently had a webinar yesterday, actually, with the Americas Alliance at SWAN. It was all about enhancing utility operations through IT-OT convergence. So we're going to share that recording with you if anyone's interested in watching. It was very, very insightful, and we'd love to hear your feedback on that as well. And for those of you who like to be in charge of things, are interested in really helping to develop the future of smart water, we're looking for passionate young professionals to really help lead and guide all of these great activities that we do at RiSWP. So the nominations are open now until July 15th. So if maybe you, one of your colleagues, rising star at your organization is someone that you think would be great at this role, feel free to nominate them or to nominate yourselves. We'd love to hear from all of our young professional SWAN members, and good luck to anyone who chooses to throw their hat in the ring. Looking forward to speaking to you. And lastly, we just recently had our 15th annual SWAN conference in Berlin. The theme was all about scaling smart water, and over a really exciting 3 days full of interactive workshops, roundtables, some really great panel discussions and keynotes. We really put our heads together to think of new ideas and ways that we can really scale the smart water systems that we've all been working so hard to develop and strengthen. So I don't want to put anyone on the spot, but I see some people in the audience that were with us at the conference. If maybe anyone wants to share their experiences or maybe a key takeaway that they had, feel free to unmute yourself. Share anything that you learned, thought was interesting, insightful from the conference. Anyone? Well, I can share my highlight of the event. So my highlight was definitely the RiSWP Young Professionals Workshop. This year's Young Professionals Workshop was all about leveling up and using gamification to help us with real-life decision-making. And we got to spend the evening getting to know each other, networking with other young professionals from all around the world, but also using gamification to make these decisions through building wastewater networks. We all got a chance to practice being hydraulic modelers. So that was really exciting and fun. There was also really good pizza at the event for all the pizza lovers. Anyone else? Dan, I see you unmuted yourself. Want to share your takeaway from the event?
Do you know what? I think it was just good to be kind of incubated around so many like-minded people on similar journeys. I think I've not really been able to have that experience before since going to SWAN. It's just so nice to kind of shoot ideas, learn some additional context, see how other people are doing things. And already it's made a big difference internally at Thames Water, in our kind of smart water organisation at Thames. I think I had a list of about 50 things that we wanted to develop, and I come away from SWAN with a list of like 150 things. So that was probably it's hard to pick one individual thing, but I think the key thing was like collaboration. I quite like the talk on co-creation as well, which kind of plays hand in hand with that.
Very nice. Thank you so much for sharing. Anyone else want to share their experience, highlights, takeaways And I'll also share here in the chat a blog that we actually just published today on our website that was written by our young professional volunteers that were with us at the conference. Also, feel free to share any thoughts in the chat if you're shy, don't want to speak on the mic. And with that, I'm going to pass it over to Naisargi, one of the members of our RiSWP leadership team. So thank you all very much. Naisargi, over to you.
All right, thank you, Sandy. I am having a hard time. Okay, there we go. I was having a hard time with my camera, but I wanted to chime in on the conference gamification workshop. I wasn't there and I missed it, but I caught up a few things afterwards, and I saw that and I thought, well, this is essentially what I do, hydraulic modeling, and it really put things into a great fun perspective that I just have a really fun job. And if I think about it as a video game, it's really interesting. So I highly recommend you check out some of the takeaways on the blog from the conference too. All right, and then with that, we're gonna kick off this teaching series. I do have Emma Grace over here at Anglian Water who's gonna share the slides, and our guest speaker today is Jennifer Morales, who is a Public Works Asset Manager at City of Omaha. A little introduction for this series. This is what we're calling the SWAN 5-layer model. This is episode 2 of the series. The first one was the introduction to the 5 layers of SWAN. Now we're getting into the specific layers, layer 1 being physical assets. And Jen here is, as a public works asset manager, I thought she's perfect for speaking to us about physical assets. And as you can see on the slides and her introduction here, she has this diverse background in working with different types of physical assets. In her current role at the moment, she is responsible for Omaha's all assets in essence, but largely related to stormwater and wastewater. She has been the member of the Clean Solutions for Omaha program management team. And you will hear a little bit about that throughout the presentation. But that kind of gives us a really good background of how we used to do things, and then how we moved away from doing things a certain way, and then how we're doing it now. So that puts everything into great perspective of how physical assets come into the picture of doing this wastewater management on a day-to-day basis, but also for the long run for future generations. And Jen's really passionate about taking care of these assets because this is pretty much what runs the world. So I'm really excited to have her speak more to it. And with that, I will hand it over to Jen. Thank you.
All right. Thanks, Naisargi. Hello, everyone. Yeah, I go by Jen. I had this weird attitude in my early career where I had to be Jennifer at work and Jen at home, or Jen around friends. And I started to realize my colleagues are my friends. We are all on a same mission, working together, supporting each other. So now I go by Jen. So it's nice to be here today. And yeah, I shared in my little narrative here that, my journey did start back in my home state of Washington State in the Pacific Northwest. I never thought I'd be a water resource type engineer. I went to school for structural engineering. I wanted to work on bridges or even do high stakes bridge diving. So there's water involved, but going underwater and checking out the structures. It really took taking on my first job for me to understand the real issues out there with what we're doing to when we have a man-made world, and what we're doing to nature and what we're doing to our waterways, what we're doing to our wildlife. So that really helped me understand, it actually developed a better mission of why I am a civil engineer, where I first started out with, I want to design roller coasters. So I have a more noble profession now, I feel. So I appreciate being here today. But yeah, in my military life, I married a military man, moved me out to the Midwest, and I saw some differences here with regard to how we protect the environment, or don't protect the environment. So I've been on a mission to educate myself, educate my team, my region, and learn to do things better and smarter. And with that, taking care of our assets that serve clean water and collect wastewater and protect us from floods, etc., are what's important. So next slide, please. Oh, yeah, I wanted to start out the day just understanding who is with us today. So if you don't mind, you got to get out your phones, and I think there's a link also in the chat that you can directly click on. If you wouldn't mind filling out this survey, just so I know who I am addressing today. So as you see, there's choices for, do you identify as an engineer, or maybe an environmental scientist, or another type of scientist, or a water operator, or technician, or any other background that you don't quite identify with one of the other choices. Let us know. We'll give you a minute or two. I think we learned we have to refresh in order to responses. Time. Hopefully you guys are willing to tell me who you are.
I think I personally hit a firewall getting to it because it's asking me to sign in.
Can you guys, since we just have, 100%. All right, cool. We got one. Great.
Let me just double check that the permissions are right for it.
Sure. And also, if you just want to pop it in the chat, just gives me an idea to who we're talking to. I tend to be narrow-minded, thinking along the lines of an engineer, but I know that the water industry, it just has such a wealth and broad spectrum, including just financial people who just love nature, just want to be good stewards, etc. So, I recognize a name. Hi, Kylie.
I'm really sorry, everyone. That's my fault. I set the permissions wrong. There's a new link in the chat now that should let you fill it out. Sorry, guys.
Great. So I'm definitely not an engineer. Okay, I love it. That's great. Hey, consultant with data science. Oh yeah, that's a good one too. I actually have a computer science intern right now working for me, and just a different way of thinking. It's good to have that diversity. All right, I appreciate you guys for answering. I think looks like we're getting a couple more in, but would like to probably going to move on. But I really appreciate it. So we are diverse. We're not just all engineers. All right, that's a good one too. There's also where are we at in our career? I was thinking the other day about what's our RIS, Rising Water Professional. You could have a 50-year-old that never worked in water that all of a sudden decided, I'm going to come into water, and I'm a young professional. So welcome. That's great for those of you who are here with that experience. Now you'll be able to call me out if I get something wrong. All right. And your location in the world. Okay, we've got a lot of North America. That's great. Europe. Oh, we have some Africa and Asia. That's awesome. I love seeing the diversity, and it will bring good solutions to this water industry if we're thinking outside the box. All right, I'm ready to move on. You guys are. That's great. So is this slide's for me as well? All right.
Yep, and I can cover a little bit of that too. So this is the SWAN's 5-layer model that I was talking about earlier. This kind of helps utilities plan and protect and manage their assets, and this is kind of what we will be covering for the rest of this series. And so today's the layer 1, which is physical assets. But what helps in general, and some of it we already covered in the first episode that we did with Andy Smith from Anglian Water, is why this 5-layer model is helpful is you can do gap analysis, you can identify the potential, you can protect the critical systems that we have, and then you can also prepare for scaling to the smart water technology solutions. So that's kind of the background of where we are in this series. But if you've missed it, this is the perfect one because right now it's layer 1. So with that, let's move on to the layer 1 physical assets, and I can hand
take it
back
over.
to Jen.
Yep. All right. So we're just on this base level. Know what you have so that you can understand what you need. And here's just a kind of a speckling of different assets in the water industry with reservoirs and pumps, valves. I don't know what some of these are, maybe boring holes, etc. But we'll get into a list of things here on the next slide. So this is just a general kind of a accounting of physical assets in the water, but in water for life. So really trying to think holistically from our water supply, our natural reservoirs, or even man-made reservoirs, our intake of that water into treatment so that it can be purified and distributed. And then as we use the water, of course, it becomes contaminated and it needs to go through a treatment process in order to become clean again and discharge into the, uh-oh, I got disconnected.
You're still on.
What do I do? Can you guys hear me?
Yep,
I can hear you.
you're still on. I don't know if she can hear us.
Oh.
That's okay. She'll be back in a minute.
Anyone have a good water joke they want to tell in the meantime?
Well, I'm not very good at impromptu humor. I have to think about my humor, which is not very funny, to be honest.
I don't have a joke, but I will share my favorite, what I would consider physical asset in just the water process, which is when I first joined Anglian Water, my first experience of the water industry. We did a tour of a water recycling plant, a water recycling wastewater plant, some may call it, and learned that we actually use bugs to help filter out some of the chemicals and the nasties in the water before it goes back to the environment, which I thought was so cool. I'd never thought that we'd use something like that, but I thought it was amazing.
I heard something about that too, and there's exactly only 2 places. I think it's clams. I can't remember, but I think it's Minnesota where this is happening. But if clams close their shells, it means the water quality is too poor, and that's kind of a prompt for the operations people to recognize the water quality.
Yeah, I've heard about this, and they've got like sensors on the clams to monitor how many of them close, and if a certain number of them close, they know something's wrong.
Mm-hmm.
Yeah, it's very cool.
Hey, I'm back. Sorry about that.
No problem.
Yeah,
We
I don't
shared
know.
a fun story that you should probably watch later in the recording.
So I'm switching from my laptop to my desktop. Unfortunately, I don't have a camera. So you don't get to see all my funny facial expressions.
That's okay. We will imagine.
Yeah. And I talk with my hands. So I'm on my cell phone right now. So I might be able to continue while I'm logging in. Let's see. I'm a mom of 4. I should be able to multitask on this. All right. So I think this is just an intro slide. I think we're good to go to the next slide. Oh, okay. So of that kind of easy list, I just want to hear what you guys have to say. Throw out some other assets that you are familiar with or you work with or you find critical. I just want to see a word cloud of what the audience understands about assets in water. And again, we have to refresh maybe.
Yeah, I've hidden the QR code because I get the sense that it won't work again, but I've put another link in the chat, so hopefully everyone can get through that.
Do you want to go to the previous slide real quick so that we can
You know what?
see what was
It's
mentioned?
all good. Let's just move on because I got the list of assets. I just was trying to make it interactive here. Oh, yes, people, but I love it. Yes. Okay. I didn't have people, so that's good. Energy. Yes. Energy systems. Definitely. Ooh, transient loggers. Okay. So yeah, the equipment that we need to measure our assets are also assets. All right, getting any more? Those are great ones. So I appreciate that. Mentioning that for sure. People, huge asset. We cannot do what we want to do. We cannot be smart without people. Even creating the technology that we use. Even problem. Oh, bugs. Oh yeah, bugs. Definitely. Now, I'm not familiar with clams as an asset. Someone might need to educate me.
That is a story you might have missed. I think Minnesota and there's one more place in the world, I think Denmark, I'm not sure, but they use clams to monitor water quality. And so if clams close
Okay.
their shells, then they know that something is wrong in the water quality. And it's actually being used like actively.
That's awesome.
Alex makes a good point. Clams might be layer 2. Maybe they're both.
About assets is so we have a definition here in Omaha that it has to provide value, but it also that it requires maintenance. So I'm guessing the clams may require some sort of maintenance in order for them to be, I don't know, plentiful. Like you have to have the right quantity of the indicator. I don't know exactly, but trying to think through provides value and requires kind of that care or maintenance and a ongoing costs associated. All right, well, I'm ready to move on if you guys are. Okay, so here, this is the list or primary categories I thought we'd dive into today with wastewater collection, wastewater treatment, stormwater management, combined sewer management, and then clean water treatment and distribution, which is not my area of expertise, but I do have some understanding. And then I threw in a couple extras, I thought, just to round it out, water conservation, and then just other water resources in general. So all uses, including fresh and salt water. And in this diagram, which I can't see as clearly now, but it basically is showing the cycle of water reclamation. So of course, the clean water source coming in, fairly clean natural water source coming in, being treated in order for it to be clean enough for human consumption, and or diverted raw for farmlands, and then going through the process of getting treated. And then that during that treatment of the contaminated water, there's gray water that could actually serve at a factory, or cooling waters, or to some sort of biological element in the environment that could take the gray water, or to irrigation, recharging our groundwater, and or discharging a treated effluent back into the river system. The next slide, please. So understanding water as a critical asset. Okay, our understanding has evolved, right? So how we save water, protect, you could use the word protect water, use it and reuse it. We've evolved. There you see some old pictures of wells, an outhouse, washboard. My husband tells the kids story about medieval times and sharing bath water. So you have one bath for the king, and then the queen takes the next bath in the same water, and on down the line. And it really grosses my kids out, but it helps put the point of how blessed we are in this day and age with the resources that we have. And so there is a motivation for us to continue to evolve and do better. Here is a photo of a river catching fire, and I believe I researched this one, and it might take me a minute. It's called the Cuyahoga River in Cleveland. This caught on fire dozens of times before anyone really cared. It took until 1969. So this isn't at 1912 or 1913. It took a long time for our society to care. It's still pretty recent if you think about it. And then waterborne diseases, we know that has not gone away. We still have issues with that. Our dams failing and causing deaths. I'm driving through Montana and you see like graveyards of where a dam has come and basically flooded a community and people died. Just tragic. And then of course, drought and water scarcity. And then again, our motivation to do better is to prevent these unnecessary deaths. Next slide, please. All right, so wastewater collection, starting there. I feel like we're a little bit behind schedule, so forgive me if I'm speaking quickly. But we have pipes, and in the pipe system, we can have smaller that serves the building, and usually is a privately owned pipeline that then flows to a public main in the right-of-way. And that's a medium-sized pipe, but then they flow to the larger trunk lines or interceptors that are larger, have heavier flow. And this is important for smart water because human access, human safety, understanding the flows in these pipelines, and also gases, et cetera, other dangers is really important to understand. How can we monitor and measure this infrastructure? We also have deep tunnels within for wet weather control in our combined sewer systems generally. And then we also have a force main system or a pressurized system to collect the water from homes and or convey it to lift stations. I'm sorry, convey it to treatment. Then our system points, we have the smallest system point is, I'm going to say it's the smallest, you guys might know otherwise, but clean out. So clean outs are generally the same size as the pipe itself. So if you think of a 6-inch pipe and you have a 6-inch vertical hole in order to access the pipe with a push cam or a jet nozzle or whatnot, they're not the best access. Manholes start to get bigger where a human entry can go in. Ours are specified at 54-inch in diameter and can go up to 12 feet easily, depending on your pipe size configuration. We also have like custom junction boxes that help again with the connection points of this conveyance system. And then drop shafts needed for those deep tunnels, where the deep tunnels are, if you're not familiar, or you're not in a community with a deep tunnel, we do not have one. It was proposed in our long-term control plan, but they are generally 100, could be 200, 300 feet deep underground. So you need these, the correct sized shafts in order to access, maintain, and construct. And let's see, so lift stations have their own components of assets with wet wells, pipes, valves, weirs. The access hatch, that's important. How do we access this lift station? It's also can be confined space entry, caustic, toxic, dangerous. So ventilation systems are important. The control system itself and the electrical control panel. And then there's level sensors or float switches to help register when pumps need to be turned on to handle the capacity that's coming in. The photos I've included is just to share some of the why we need to understand these assets. So one photo is of water just pouring in between a riser ring on a manhole, and that is common in gravity and combined systems, and it leads to excessive flow in the pipe and stolen capacity, and also exacerbating the treatment plant, sometimes leading to a manhole or sewer overflow, sewer backup, or an CSO, combined sewer overflow. The other picture is of a manhole channel. That's also really important if you want to do flow monitoring. So the configuration of that channel will help. If you have good hydraulic conditions, it helps your measurements be more accurate. And then if you have a bunch of junk and debris in there, that's really going to affect how well your metering is effective. And then that's just some components of a manhole as a diagram for those who might learn from that. All right, next slide. So again, with starting with our wastewater system, we have both pressurized and gravity networks. Water also primarily uses pressurized networks, if not our primary, yeah, all are. Our stormwater are primarily gravity networks, but there are cases where you will need pressurized networks, especially in the case of Omaha. We have stormwater collection behind a levee. So we have a Missouri River levee, and we have to get storm out of our, depressed, sumped city out to the river. And then wastewater networks again, are combined of pressurized and gravity. And the pressure systems can be very small. Some of these homes, like for example, this picture just shows homes on the gravity. There are homes that can be built lower than your mainline sewer, and they need a grinder pump and like a 2-inch line in order to get their wastewater up to the gravity system. Next slide, please. All right, so here's just a couple of photos, for example, again, of a wastewater collection system. The top left is our Bert Izzard lift station in Omaha with some of the pumps and the force main pipes involved. And I have this picture because one of the things about designing new assets and aiming for a future of smart water measurement is you need to have good accessibility to the components that you want to measure. So an engineer needs to think ahead about how can this machine, this system be accessed and a measurement device be added. The next photo toward the top right is preparing for a flow meter installation on a very toxic interceptor sewer system where oxygen has to be pumped in, lots of air monitoring and confined space entry safety protocols in order to get that measurement device. And understanding the condition of that manhole is critical as well. You don't want to put your person in the harm's way of entering a manhole that actually could crumble into them, on top of them. The lower left is a photo of our Missouri River wastewater treatment plant with, you can see a lot of above ground components, but that is a flooded plant right there due to our 2019 Missouri River flood that we dealt with. And then the middle lower is just a 360 camera, another technology in order to gather data that can be smart and used to help triage and plan for system repair. And then we have a case on the lower right of probably poor design and or unforeseen erosion along a creek where a manhole on a sanitary system was constructed. And now this manhole has become virtually, I mean, maybe there's a way. We're engineers, we can problem solve. But right now, it's not very accessible manhole to understand what's happening in the system at that point. Next slide, please. All right, moving on to wastewater treatment, or some refer to it as water resource recovery facilities. So again, this isn't just about treating the water, it's about gaining that water back for society. We need to get that water back in a clean state. So we have, in wastewater treatment, we have a primary treatment that includes screens, grit chambers, primary clarifiers or sediment tanks, pumps. In our secondary treatment, we have aeration basins, sludge digesters, media filters or trickling filters. You know, I'll share a story of our own trickling filter that's 180-foot diameter. It's one of the largest in the United States. And it, we are trying, I can't remember its age, true age, maybe, man, sorry, 50 years. But it had a catastrophic failure a couple years ago. And I think we could have foreseen it with some smart technology. If you're not familiar with trickling filters, there's these big rotating arms and the water flows out of orifices onto a medium that is growing the bugs, those important assets of bugs that help treat the water. Well, the whole mechanism, this huge, like 18-inch diameter bearing just exploded. It completely fell off its rocker, if you will. And I do think a smart technology, a better plan of monitoring that system could have given us some indicators before its catastrophic failure. And then the energy, someone mentioned energy. So yeah, and we have energy recovery to think about. What are the components involved in that? And then other specific components, again, with the basics of pipes and manholes, pumps, motors, valves, tanks, blowers, and electrical panels. We've also learned in Omaha that our electrical systems have been kind of neglected or put on the back burner and now have come to a forefront of as a critical asset. Next slide, please. All right, we're moving on to stormwater management. Looking time check. All right, so stormwater is interesting. Stormwater is one of those things that I find everybody wants to do better at, but it's hard to find true owners of the stormwater assets. So there are these physical assets out there with pipes and conveyance, with culverts, thinking of it as conveying a waterway from one side of an obstruction to the other side. It's not necessarily for stormwater management. It's actually because we interfered with nature. And so we have to build a culvert in order for that water to go where it was supposed to go or where it wants to go. And then storm system pipes, of course, we have channels, open channels, flumes, weirs. We also have riser pipes we use in our best stormwater management best practices. And there's force mains, as I've mentioned before. There's a question. Should we take a break? There was a question that rolled in.
Yeah, I think, Jen, it's up to you if you want to do the questions at the end or if you want to answer it right now. The question is primarily related to the pressure networks. So if you want to answer it now, totally up to you.
Okay. I might wait then. I might wait till I get through water. All right. So moving on. So within our stormwater system, we do introduce other structures such as the inlets themselves. So the intakes of the stormwater, or even on a culvert, whether the culvert is built with a nice head wall, wing wall in order to prevent some of the erosion. We also have our outlets of the stormwater, so how it discharges to a waterway, and those outlet designs are critical in order to protect that waterway. So it's just something to keep in mind for design and what's in your inventory. And then our manholes themselves, again, give access for cleaning, inspecting, and also serve as good as junction points for pipe connections. Best management practices are also part of the stormwater management system. So for us, I'm not sure if everybody uses the term the same, best management practices, BMPs, but here I am talking about our erosion and sediment control structures and or designs, and then detention and retention basins, catch basins, grit, and then other green infrastructure. All right, I'm ready to go to the next slide unless we need some dialogue there. All right, so I've gone over wastewater, gone over stormwater. So now there's this interesting stormwater, wastewater dynamic. And we touched on a little bit about the combined sewer overflow program. Approximately 700 communities are still discharging raw wastewater into our creeks and rivers. And when I found this out as an engineer in 2004-05 timeframe, I was completely disgusted. I could not believe that we were in this modern era. This is what we were accepting in our communities. But it turns out I was just kind of a young, naive engineer. And I learned that even my own home state of Washington had combined sewer overflows. And for those who, if this is not a familiar term, it's a single pipe that wastewater is conveyed. And when it rains, the stormwater adds to it, and now you have both stormwater and wastewater. And so you could say, oh, dilution, solution to pollution. So yes, it's diluted wastewater, but it's still, I'm sorry to be gross here, it's still direct turds going out to the river. I swam in one of the rivers that discharged CSOs. And I also learned this the same year I had my first child. So, when you have a child, you start to think, what is the environment they're going to grow up in? So this really helped with my passion for clean water, protected waterways, for sure. And so in that combined system, you have a lot of the same assets as your wastewater and stormwater, just with a few exceptions. And one would be, I would touch on diversion structures. So this is where wastewater on a dry, no rain, wastewater is going to the treatment plant. It's not going to the river. But then the rain comes in, and we still don't want to just send it straight to the river. We want to send as much as possible to treatment. So the diversion structure and the controls in those diversion structures, which include weirs and gates, riser pipes sometimes, those help maximize flow to treatment. And that's also one of the 9 minimum controls put out there by EPA. But then you reach that threshold, and guess what? It's going to the river. So we hope to catch the strongest strength waste. I just said redundant. The strongest waste to treatment and the less pollution to our waterways. But it still happens. So we also have screens and grip pits, and the screens to help us with floatables control. So imagine if you have the inlets in your community like we do that are big open holes, not grates. They let a lot of pop bottles and trash and whatnot. And so the screens help before a CSO discharge. And also there's the grip pits in general, grabbing the other solids out of the, letting the solids settle out before it goes to the river. And then the other thing is strategic storage tanks where you actually hold back during peak flow times, the combined sewage, and then slowly release it back to treatment, preferably then to the river. And within our community, we also have partial treatment or high rate treatment involved in our system, where it just goes through a primary or a disinfection, kind of a storage and a settling of those solids before it discharges to the water. All right, I'm ready for the next slide. Might need to get a move on here. We just have a couple examples here. I do have on the left is that is a stormwater discharge point perched up about 10 feet. It's because partially due to the erosion that has occurred that it's that high. And if you look closely, there are actually 2 inverted wastewater siphons that are not supposed to be exposed in that waterway, and we have to monitor it frequently for leaks. SSOs is what we call them, sanitary sewer discharges. There's something probably that could have been designed better here, but we have what we have now, and we need to do what we can do. So this isn't a project improvement list right now. And we have the example of a riser pipe, and then I just have a picture of one of our oldest brick culverts, and kind of all the nuances involved with that is we have a lot of storm sewer system taps to that, and those have bad connections and now have eroded behind the wall, so they've impacted that culvert. That 100-year brick culvert could have lasted, but because of the taps to it has been subject to disrepair, and it's dangerous now, and there's a roadway over it. All right, next slide, please. I missed if you want to go back, I did miss highlighting the upper right is our high rate treatment. We call it Saddle Creek. It's for our CSO program. And that's the discharge over the baffles before it reaches the creek. All right, next slide, please. All right, on to water distribution, my favorite. So I'm not a water expert, but what I do know about water is in my early design years, I had to design water, at least enough to reach my development. And the one thing I remember about water is we never knew exactly where it was. And you could say the same about sewer, but now that I know what I know, I feel like sewer's a little bit ahead of the curve on knowing where those items are. But water is a challenge. And I know there's like probably tracer wire, and there's other things that can help. So with water, we again have pipelines for distribution. There are varying in size with service lines and mains. They're all under pressure. Some are even under a high pressure. And then there's varying materials like PVC, ductile iron, copper, and even lead. And I know EPA is going through encouraging getting rid of lead pipes if they're in the community. I don't know if it's encouraging or regulating this. And then with the system points on water distribution, again, we have valves and pumps. A new one here is fire hydrants. So that's important for the community. And as we learned with the fires in California, having adequate water supply and access to that water is critical. And we also have manholes. Usually within the manholes are valves. And then backflow preventers is another one that's very helpful. Water, and then the water meters themselves, so we understand the usage. And then for facilities on water distribution, there are boosting stations that help increase the pressure so it can reach its destination. Storage facilities like water towers And then we also have the treatment facilities, of course, which I'll have that on the next slide. Next slide. Thank you. All right, so within our water treatment facilities, I thought I'd just highlight a few things within the treatment. We have our intake structures. There's basins where they do a coagulation and basins where they do flocculation. And I'm not a water person, so maybe someone else on here knows all about that. But I'm guessing it's adding chemicals to extract the crud from the water. And then sediment, of course, sediment basin. There's dosing, not only for the coagulants, but I'm guessing there's for a little bit of chlorine, I would imagine. Storage tanks, pumps, pipes. And then this last one is something that is true for wastewater as well. And it is a critical asset, I believe, and it is the laboratory. So it's something that usually is within the facility. It takes its own care. It has its own equipment, and the equipment can get aged, or meters could be not tested right, or calibrated. There you go. That's the word. The equipment could be missing steps. So it's important to care for your laboratory as an asset. Next slide, please. All right, so here's just probably going to speed up a little bit. So here's some photos of water treatment assets. So there's yeah, you got the pumps and the dosing and the sediment basins, and then you have the people, important people assets working, it looks like at night. So this was an emergency, likely an emergency, turning something on or repairing something, I'm not sure. All right, next slide, please. And just wanted to touch on some things that haven't been mentioned yet with other water resources and conservation. So we have our natural features, rivers, lakes, aquifers, wetlands, and watersheds, the vegetation. And even though those are natural, they're still assets to our world. And they do take care, need care, especially in a world where man is coming in and destroying those natural features. And then our man-made features, we have our mitigated wetlands that need to be treated as an asset, not just mitigate a wetland and walk away and never care for it again. We have planned vegetation. That vegetation needs to be cared for in order for that water feature to do the work that it needs to do. We have reservoirs, irrigation systems. I have a list of what's involved with those, with spigots and I didn't even put spigots, sprinkle heads, nozzles. Then rain harvesting, so catchment of the rainwater, the conveyance and storage and filtration of that. And then fish passage. I thought I'd end there where I began. So that's where my career started. And just reminding everyone that that is another piece of water resources, is making sure there's correct conveyance for our, well, safe environment, safe habitat, I should say, and conveyance for fish that need to go back to a certain area to reproduce. And with that, we'll go to the next slide. So I wanted to highlight several important things to know about your asset, especially if you're embarking on any kind of smart water program. So understanding what you have and giving it a unique identifier is critical. Knowing how old it is or when it was built, I think, is a very important piece of information as well. It can help you with that life cycle planning. And then understanding the material it is, because that will also help you know how long could this thing last, or what is it subjected to for deterioration, such as concrete, sewers, concrete used for wastewater conveyance is subjected to H2S corrosion. Knowing the size, or not just the size, but the capacity that it's supposed to serve, and then so that you can measure, is it operating as designed, as needed, as intended. Understanding the depth of the structure will help you also understand planning for maintenance, as well as planning for any kind of repair, any financially planning to take care of that asset. The flow depth and velocity, and thinking largely about wastewater here. And then I put pressure rating. I'm guessing that's something for water, water and or lift stations, things we need to know. You could throw in pump performance curves. I'm sure there's a number of things we could throw in there. The other thing I think is really, really important is understanding its actual location and its accessibility and its location in proximity to other things. So the physical location, a northing, easting, or if an XYZ, Z with being your depth, or and or the physical address. And then the spatial relationship, again, to other things in its own system or to systems that are above and below. For example, in City of Omaha, we have high pressure gas mains above some of our oldest, most riskiest sewers that are out there. So understanding the assets as a part of a kind of a cohesive system to serve the community. That's a dimensions to other assets. And then the human or machine access. So I mentioned that before is really important. So with that, how do we understand those things? Well, record drawings, there might be manuals, field confirmation, basis of design reports, published O&M manuals need to be readily available and shared and transferred for transfer of information, not just kind of hidden away, collecting bugs and dust. Condition assessments with photos and with the date that the condition assessment was done. And then I mentioned for the first time, I believe, is the Precious Geographic Information System, GIS. This is just a wonderful, smart tool. I think it started in the 90s. I was lucky enough to work on it in 1998 and have realized what an essential value it is to managing, especially these utility assets. And then lastly, it's important to know who owns and operates these assets. So the people are the asset. So knowing who can we go to, who knows, who's the subject matter expert, or who has the institutional knowledge. And then I invite you to get that out of their brain and into some sort of smart documentation system. All right, next slide. I've mentioned the consideration to other assets. So this is just, again, reemphasizing roads, stream crossings, utility crossings, etc. And a reminder that GIS is a tool that can help you understand how these all kind of overlap and intertwine. Next slide, please. Okay, I think we're getting there. Lastly, one of the last things, environmental considerations. Again, we're doing this because if we don't protect these assets, we could be impacting the environment and impacting the services that our community needs. With leaking pipes, excess power consumption, maybe the type of materials the pipe is could be leading to health problems or excessive corrosion. The overflows, again, with the polluted wastewater laden overflows, and then also pavement cave-ins and sinkholes, but washing out of bridge piers, etc. And we also can impact, the environment can also influence our assets. So understanding how the sun, corrosive soils, our groundwater presence, what materials and what environmental effects lead to rust, erosion, freezing, etc. Next slide. Trying to wrap this up. All right, I think we're there. All right, so this is just smart versus not so smart. We've come a long way, we really have. And I think, I don't even like the not so smart. I think we've just been evolving. We've just been getting smarter and smarter and just building from each other, learning from each other, lessons learned, using our data. I saw someone just pipe up. Yes, learning how to use our data better, understanding data as an asset in and of itself, I think is important. It does serve a value. It takes care and maintenance. It has a purpose. And so that's a big one to point out. So I put, we're going to get smarter through integration of advanced technologies. So the next level from learning about these physical assets is some of the advanced technologies with sensors, data analytics, and our communication systems. And these do enable more real-time understanding and decision-making to prolong the life of our assets and to provide a better quality of product, if you will, a better quality of water to people, of water to the environment. And then technology that's already in place, that's pretty smart. We're very smart to have, for someone to have invented GIS and for us to make it mainstream now. It was not mainstream in the 90s. It was this new weird thing. And now it's so almost can't live without it. That's how I feel anyway. We have our computerized maintenance management systems, or some have enterprise asset management for tracking work and failures, and can get patterns of failure from that. What works, if you want to try a new program, try it, measure it, circle back, tweak it. And then our digital data collection and condition assessment. So kind of that real-time data collection, I think, has been a phenomenal advancement with field maps, Esri field maps, where a manager, engineer, field supervisor in the office can see exactly what their field workers see. And then our flow monitoring, I put with or without telemetry. When I started, there was this big debate of do to telemeter or not. And now it's not a debate at all. It's like, duh. Telemeter, you gotta get to that data now. You can't wait 2 weeks, 4 weeks to download that data. That is a complete waste of money. So I'm so glad we've made that evolution. And then the hydraulic model, I heard some of you guys get to test being a hydraulic modeler. That's great. So I need to end so that my compadres here can wrap it up. But we do have the next SWAN learning session, is that next step of sensing and control of these physical assets. Take it away, team.
All right. Well, thank you, Jen. That's a lot to absorb, and I actually learned so many new things today. So we had about 2 or 3 questions in the chat. If you want to take the time to answer that, and those who asked can stay on. Those who cannot stay on, they can drop off. Not a problem. But for the questions, we have 2 questions on the pressurized systems. One is, what are your thoughts on pressure vessels for the pressure management below ground, considering what's on the market and current technologies? And then the other one is, it's kind of builds into it too, is, have you worked on pressurized sewer systems that were predominantly below ground? And how have you managed gases and air below ground?
Very interesting. So I don't think I'm super familiar with pressure vessels. If I have to use my imagination without going to AI, is that like where it would give a pressure boost, like how you would have an oxygen vessel? I'm not sure what that is. That would be, if someone else knows and wants to chime in on that one. But I can answer number 2. I am familiar with pressurized sewer systems. I've never designed one, but I've adopted them as my babies. No, I'm kidding, as my children, my asset children. And they're very challenging, and air release valves are critical. And also understanding your alignment. I know we've learned that some of our pressurized systems have a lot of peaks and valleys, and yeah, the gases are a problem, and they do lead to corrosion. And so acquiring the new asset, getting a good construction records, as-built drawings, et cetera, is imperative.
Yeah. All right. Thank you. And then one last question was, which smart documentation systems do people recommend?
So I think
Maybe
I said that.
Question.
I might have said that word, and what I meant by smart is the smartest thing we can do is to have a single source of truth, and not each having their individual side list of things. So anything that integrates information to a central location is smart. It could be a number of things. I know the city of Omaha, we're using Trimble Unity Construct for our project delivery, but it also is being used for some planning agendas, even organizational planning, like APWA self-assessment, for example, if you guys have heard of that. But we also use CityWorks and Maximo. I think it's understanding what that software solution provides, and creating rules. I think that's where we've struggled, is we haven't created enough common rules so that the information in isn't garbage. Information in, it has value, and when a person needs it, they can trust it and get what they expected out of it.
Yeah. All right, one more question trickling in. If nobody has other questions, this is probably the last question we can take in essence of time. But if you have more, you can send them to me and we can get them answered via email too. The last one here is, in your experience, is it the technology, the people, the processes, or the funding that need the most advancement for smart water to succeed? Kylie, it's everything.
Yeah.
But Jen, go ahead.
Yeah. I mean, I think it's people first. People first. You have to have buy-in. You cannot be a single lone champion. I know that route. You don't get very far very fast. It doesn't even matter if you have money. You can't get it implemented if you don't have people on board that it is the right win, that it will bring efficiency, that it will bring better service. So people, number one. And I think technology can help us even with the convincing that we need to do. Like, I use GIS a lot just to make my business cases, my arguments, do a lot of data analysis first before we can even buy the next technology, just to say, this is why we need this next level. And then, yeah, processes, it goes back to, if you don't have good processes, especially for your data coming in, then it becomes unusable. So they're all very important, but people first. Where is Omaha Digital Twin evolution? I would say the buy-in is not, the buy-in that it's a need, necessity is not there yet. What do you call that? Return on investment is not there.
All right, well, I think that's all the questions we have. Thank you, everybody, for your time. Thanks, Jen. It was a great presentation. I really enjoyed it. Thanks, Emma, for all the slides management. And everybody else, if you have any more questions, let us know. This will be posted online. It was recorded. We will also send out the slides. So thank you. And with that, I will hand it to Sandy for final closing.
No, I think you guys got it covered. Thanks again, Jen. I think that this was definitely one of the most fun SWAN and risk calls I've ever participated in, as well as one of the most informative. And thanks again to Naisargi, Emma, and the whole team behind the scenes. And yeah, have a great day, everyone. And really, really looking forward to the next one. Good to see everyone. Bye.
All right.
Thank you.
Thank you.
Bye.
Thank you. Thank you.
Bye.
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 Thank you.